All right. Gonna start streaming here. Are we live? Looks like we are live. Let's go. Pull up Zig, documents at Zig. And yes, that's the one I want. Nice to have that reference manual up all the time. Okay. So looking through the I'm gonna get back to working on my Manpage generator today. And stop I program. So I don't know how much talking I'll do today, but I want to just really focus on figuring out what the best way to move forward here is. So I've taken, for those who haven't seen the previous stream, I'm working on a manual page generator. So something that can generate man pages or documentation that can be viewed in the terminal for Zig. So Zig already has an autodocs tool that allows it to be used with that allows it to be viewed on the browser. Sorry, I got distracted there for a minute. And I want to be able to kind of open up in a Manpage viewer, which can be really nice. That's how I like to work with C when I program in C. And so it'd be nice to do it with Zig as well. So yeah, what I've been working on at this point right now is this extra AST viewer, a little viewer to help view the AST because oh look, I've got this already watching. Okay. What the AST viewer will do, move my mouse out of the way, is, or rather what I need to do is walk the AST and identify all of the, I'm gonna move my microphone here a bit there. I need to walk the AST and view all of the different nodes and really find identifiers that exist in a file, and especially the public identifiers. Find their documentation comments and then link them together in a way such that if we look at like a standard Zig doc, Zig, let's just search Zig for, look at, yeah, that's what I thought. My search isn't working right. But if you look at this, you can see Zig. Oh no, it did pull up standard. Yeah, standard, which is a struct. It's also just a namespace. But it's a struct, and you can see the source of all of that. If you want to go there, which is cool. And then you can see it has types, and so it's put all the types together in a place where it links to them, all the namespaces together, where it links to them on different values, like that. And then the one function that I guess exists, the one public function, and standard, which is once. Interesting. But anyways, it'd be nice to be able to build out something somewhat similar to this in a Manpage viewer. Won't exactly look like this, obviously, but it'd be nice to be able to do that and then maybe provide capability to search through it and link through it and that whatnot. But first, we've got to be able to parse the data and display it in a way that can be displayed on the terminal, which is why I'm going with Manpage right now. But maybe in the future we do our own Manpage viewer for this that allows us to maybe display it in a different format, like Markdown, in which case all this would be not really useful work, but we'll see. Anyway, so when I was looking at that, I moved the mouse again. What do we got here? If you look at like decal, no. we look at how it's done for Autodocs, which is what generates the online documentation, we could see that it goes through and this is the main. And walk, you can see that, well, what you can see is it goes through and it categorizes every declaration that it finds as it walks through the AST. So, const file index get AST, node tags, items, and then you get to anyways, looks at all the node tags, looks at all the token tags, and then it switches on those node tags and goes through and it says, hey, if it's the root one, look, here's what we're going to do. We're going to go through all the root decals, get all the members, and we're going to switch on the member. If it's a field init or field align or field, return container equals node. Interesting, because what we're doing is category. We're returning some category, which itself is a group namespace, container, global variable, function, primitive, right? All of these, which are unions of an enum. And so it's a union, meaning it's in Zig, if you're not familiar with Zig types, you have enums and you got unions. And enum is just like a tag. And then a union is a tagged union, is what you could call it, where you can take the tag and you can also put on data with it. So it's more like a union in C, or a enum, I think, in Rust. An enum in Rust is very similar to a union in Zig, whereas an enum in Zig doesn't have a very good corollary in corollary in Rust. So I like it. I like being able to say, you know what, here I just want the tags. I don't really care about attaching any data to it. And then if you want to attach data to it, you can use a union. Anyways, that's our little Zig facts for you right there. So anyways, it goes through and it categorizes all the declarations. Does that for root. You can see for global variables, local variables, simple variables, and line variables, it does some variable decal. Look, AST, what is file index get AST? It's the AST, okay. So it's going through and getting it. And it's going to categorize that expression here. And you can see it does the same thing with functions. So you can see it goes through and it categorizes functions. And the categorized expressions will then further trim it down to the certain kind of expression that needs to be. Same with categorized function. See all these different expressions. You can have like a field access, a built-in call to, comma, built-in call, comma. All these different types. And really, I wonder, part of this I'm just trying to understand how this works. And so as I was working on mine right here, and I had a categorized decal function. Is it walk? Yeah. Where I was going to start going through, but I want to walk through the AST and see how that works. And so I wrote this extra tool called AST Viewer, and it just kind of prints out the AST. So this is AST of one of my files. This is for Mangen, so the main file. And you can look through it and you can see you've got the root, We got the FN proto simple. This is what the looks like. You have identifiers, function declaration, identifier, field access, struct init 2.2. And so I was trying to understand how this works. Let's let's go to Mangen. See, Manpage generator. Okay, and then we got the function, main function. Let's see any other functions. Let's do fatal right now. Fatal, fatal, fatally kills the process. So then we should have in here, right? I didn't like. Ideally, you'd find, I think, some kind of thing. So this is where I want to go to AST. Let's go back to AST nodes. Out of the way. We go to node. You look at the tags, and let's find what's it called? Doc comment. Yeah, container.comment. So actually, here in tokens, all true switch tags we're trying to find return. It's returning a token index. Oh, this is like a wild true switch. This needs to be changed to a, well, it doesn't need to be, but switch to. So what happens here when we get to container, checking if the token tags are container.comment. Okay. So actually, the AST nodes don't contain. If I go back to AST node, look at the tags here. I don't think we'll see a dot comment anywhere. Okay, that helps because that's why it's going through the tokens. If we go through tokens, where's token? Token list. There you go, token tag. Here in the token tags, the Zig tokenizer, then we'll see dot comments. Dot comment, container dot comment. And identifier. Interesting. Okay. So if we go back to looking at we go back to looking at categorize declaration function. It's switching on node tags. Now, look, node is the index because look, it's an index into the AST. So we're saying, hey, at this at this node in the AST, give me the tag. If it's a root variable, if it's the root tag, okay, what we want to do is switch on node tags member root decals. Root decals takes in a tree, gets the nodes data, tree nodes items, the data, okay. And then it's going to mode if it's Zig and Zon. Okay, if it's Zig, which is what we care about, it's going to get you the tree extra data for node 0, that left-hand side through nodes data. Oh, okay. And so that's how you get all the root declarations. Interesting. So it turns an array of indexes into nodes. Okay, so okay, that makes so much sense. So I know this because I was working in my AST viewer and I was thinking, so if we look at my AST viewer, which I've commented out a bunch of stuff, I said try format, I wanted to format AST node, which I didn't do because it was getting a bunch of errors. In fact, let's just build this. If I run this now, you'll see, oh gosh, all this ugly hideousness that's wrong. And that's because I was thinking when you go through the data, because it doesn't document it very well. When you go through the AST, you get these nodes. Right, so I'm saying, hey, here's the node I want to format. And that's how it works. Is you give it a node you want to format, which at the beginning is going to be the root node, and you say, give me that. You take a look at that root node. Sorry, lots of things going through my head right now. And you get its tag, and you get its data. And I was thinking data, so data, if you look at data, where if we go to, let's see if we go to AST, you'll see that in AST, every node has data, and the data is just a struct where it has a left-hand side and right-hand side, which are indexes. Now, I was thinking because the indexes belong here, that they're indexes into the node list. But they aren't. These are indexes. In fact, I think node index, is that a thing? No. Like, okay. You can see each thing. So if we go to root, is a sublist. Oh, okay. So then everything that's under the, okay, this is all these comments are telling you what to do. I just didn't understand. That's all. I'm not dumb. It's just that I didn't understand. So you got is in the extra data token, because if the data just fits with the right-hand side, left-hand side, that's great. But if it doesn't, then you need the extra data. And the extra data gives you an array. So if we go to extra data, see, some of these, LHS is the index into extra data, RHS is the initialization expression, if any. Main token is var or const. Sorry, I'm just looking at how it looks at different ones. But for the root, you get this sublist. And then for using namespace, the left-hand side, using namespace, LHS. RHS is unused. Main token is using namespace. So in that case, I think LHS is the index into the node list. But because I was using the array here, let's go back and run AST viewer with my old thing. We look at this. We have main token is 0, which if we go back to let's go back to AST node. The 0 is, that's right. If you look at index, AST, where's the O? Oh, I thought there was a note here about it that just said that because index, you can't have an index to the root. You can't have a reference back to the root node. The root node is the root node. You can use 0 to mean has no root, or rather has no, that there is nothing there, right? And so if we go back to main token, oh, it's a token index. Oh, okay, never mind. Forget about that. Anyways, then you see data, and data says Zig AST node def. Data left hand side is 98, right hand side is 106. But instead of being 98, I was thinking 98th node in the thing. I was like, that doesn't make any sense. What it is 98 through 106 in the extra data space is where all the root nodes indices are contained. So if we then take a look at where extra data is, it's on the AST. Which is type index, basically. Extra data has a bunch of indexes, so there's more. If you need more indices than just 2, U32s. Okay. So if we go back to my AST viewer, what I need to fix here is, is that when I go through this, this has to be, we have to switch on the tag. So let's do this for, interesting. Yeah, so to view the AST and to walk it, you kind of have to write for every tag because it's different. For every tag, what kind of data structure you're actually looking at. So let's start writing. And actually, if we go to categorize declaration function, I think we're going to get some hints on what happens, because if you look at the root, it's going to say, get me the root decals. Whereas if we go to var, we get full var decal. And this handles how to get a global tree. So what is tree? Tree is AST. Do these functions come on AST? Because if so, that is so helpful. Full var, oh, it does. That is nice. Okay. That means most of this is already done for us. In fact, at this point, now that I understand what's going on, I'm much more inclined to just copy. More inclined to copy the implementation, excuse me. Because really, I don't really care much. We can go through and modify things if you want to. This walk function, particularly in the file. So I just copied all this Zig AST, assert, standard lock. So this is all standard stuff there. The only thing that's different is decal. So where's this used? Everywhere. Okay. It uses decal index for the category. Okay. Okay. So that decal index is really key to a lot. So maybe we look at how this works. No. Oh, thank you. I've been thinking about making another video for the uninitiated series. I just about strings. In fact, I recorded one about Zig strings. I just I recorded it, but then when I got to editing it, none of the audio recorded, and so that was maybe like 2 months ago, and I just haven't gotten back to actually recording it. No, I don't do vibe coding. I don't have any AI co-pilots or anything like that. Just trying to understand some Zig code. Anyway, so maybe we look at the decal. Let's see. Yeah, maybe we go to this file. And we see what's going on here. So decal it contains an AST node, some file, but actually just an index to the node. File, so just a handle. Same thing, another handle into its file plus parent, which kindly they've annotated. This is the decal whose namespace this is in. So if the decal is what's it called? Whatever. If the decal is a struct or something like that, it can also be a namespace. That works. And if you look at the index, you can see that there's a default none for the max int. So if the value is the max integer, that's none. That's for case if something is a root, has no, containing namespace, then you do that. Okay. Public const extra info. So actually, I'm curious. Let's go to array hash map. Is this how they standard array hash map? Standard array hash map. If we go to array hash map, standard doesn't have any parent. But is that the only one? I mean, everything is in that. Is everything in that namespace? How do you know? I guess you enter and you crawl through all of them together, so you don't make them per file. Just make it all at once. It would have to be that way, I think. Okay. Then it has this extra information struct, which contains is it a public file? So it's just a public thing. Its name, nice. And this might not, oh yes, and the first dot comment. So it's an index to a token in the AST. Now, if it's not a dot comment, which it might not be, so you have to check in here, there are no dot comments, which can happen. And I've already walked through the logic that they use to find it, and so that makes sense why they do it that way. Okay. So then you have this categorization process. I don't know where this is used. Hit child by name. Okay. Okay, so children of it can have, if it's an alias, then it needs to get the alias C. You can just go get the original thing and get the child. Okay, if it's a namespace or a container, you switch on that and you say, here, give me the node. Categorize gives you a category from walk, which we just looked at. Get type function return expression. So categorizes if it's a type function. And then it's also used in looks up the decal by name accessible in decal's namespace. Okay. That's all that's used for. Okay. So I don't know how much of that we actually need, but I do know we need pretty much everything that's in walk. So we might just need to copy this file over and shrink to fit. And see if what that generates for us if we use it. Why not? Let's do that. Okay. Okay. Where was I gonna go? Oh yeah, we're gonna copy those files over. So let's we're gonna copy cp ast lib docs wasm walk.zig to dot, and we're gonna copy decal.zig to dot. All right, and now we're ls. Oh, move walk.zig to ser/ walk.zig. Move decal.zig to ser/decal.zig. All right. So now if we go to our decal, haha, so it's IT. Yay. Add the MIT license on here since we just copied that from Zig. Now let's do walk.zig and do the same thing. There we go. Oh wait, no, that's the wrong one. Walk.zig. There we go. Okay, so I'm already gonna go and edit some things here. Let's say, no, I don't really care about the sign. We'll figure that out later. But also, just keep in sync with cat. We really don't care about main.js. I'm gonna get rid of that for there. In fact, I'll make a note here. In autodocs, this needs to be in sync with a JS file. Where we are going, we don't need any JS. Okay. But where we're going, we'll keep these because this is a useful file. So I was gonna have a file value here. In fact, I think I already have a file. Okay. So walk, if we go through walk, I think the main entry point to walk is this is where I had trouble, where I kind of was like, I don't know if I want to use this. It'd be nice if there's a way I could just like view all the public functions. I know there's a way I can just do hub. Those are only two. Oh, it's not tab. Hub. Okay, here's all the child lookup token. Okay. So this is where we go back to here, and we go to main wasm main.zig. Where does walk come into play here? Walk at decal. Ah. There's the decals items. I go to walk. I see that it has a decals. Container level variable, which is empty. So presumably this gets filled at some point. Let's find all the references to it. So here in index, you get, okay, so index, where are we at in decal? Is it's indexed into the walk. Okay. So that's its index in the walk decals variable, okay. A little confusing, but here we're using it there, okay. Okay, add decal. That's in walk, which has an index. Okay. This must be the index of file because it's being used that way. It's appending into decals. AST node. A node. It gets tries to get i.get, which is index get down here. No decals. I.get is a file index. Takes reference to files, which is, I'm guessing, also up here. Okay. It's a global. Files values, because it's a hash map. Okay. And gives you the int for enum I. So it's values, list of values, and it's giving you the ith value in it. Okay. So then you get that index, no decals, because the file has no declarations on it. Okay. You're putting into it. Let's go to no decals, which is an array hash map. So this maps a node to its declaration index. Okay. So then the question is, where was I looking at now? Oh yeah. So this is where decals get added, appended to when you add a declaration in a file. So the question is, where is add decal used? In add file, in a function called struct declaration. I think this is also struct declaration. Okay. So let's take a look at add file because it's a public function. It's never used, at least not as far as we can see. Okay, walk to add file. For some reason it wasn't picking up here. Cert file equals try walk to add file, file name. So here, when we're walking, it's walking through and it's adding file, which when you add the file, okay, this makes sense. Unpack inner. It goes through a tar file. It files it up and says, hey, or untars it. Goes through each file. And then standard mem ends with U8, Zig. Make sure it's a Zig file. Then it's going to duplicate the file name. Okay. So we can keep it around, I guess. And if the mem index of scalar U8 file name index of scalar, which I remember right is like gives me return linear search for the index of the scalar value inside the slice. So it says where's the slash? I've used this before. Basically looking for a slash in file name. Const package name equals file name. 0 through package name end. Okay. Get or put walk modules. Get or put GPA package name. So it's going to put a package name. Then it's going to file. Makes a file index enum. Okay. Gets walk files entries length. That's the index into it. It says if get or put found existing. If not, so if it wasn't found, if it wasn't already existing, or if the name end through 0 is root the Zig, or the name end +1 through file name that length minus that Zig that length is equal to package name. Package name end. Package name end +1. So if you skip the slash, where'd file name come from? File name dot length. Oh, through file name dot length minus dot zig dot length. Guess if it's like a basic file, then yeah, it would be maybe. I don't know. You get a put pointer, value pointer. Basically, it's putting in that file. Otherwise, that's for modules. So it's just making sure we have a module tracked in there. Okay. So this tells me is we need to walk through all our files and do walk.add file. File bytes. Just tar bytes. 0 through incast tar file size. That's it. That's cool. But we're not tarring anything. What we do have is this. No, this. So what we're doing is we're going through and we're getting the source data, parsing it. Bloop, parse. I don't know if we actually need to do that. I think all this is handled. Well, no, we do. We need to send it the source bytes. Right? File bytes. And so that's the adjusted source. But this AST stuff, I think, is handled by the walker. If I go to walk, it's at the bottom here. Const walk equals at import. No, at import walk.zig. Okay. So then if I do here, I said file kind is file and it's a Zig file, then we're going to make a thing for it. So we're going to say reading file. Blue. We get the source of it. And so kind of similar here, we need to add. We don't need to add. Well, we might. I don't know if it'll break the rules if we don't add that module. So let's do this like it's been done in here. Just copy what they have here. they're getting, oh, because they're using tar. So the word tar file name. Where are they getting file name from? They're duplicating the name. So here we'll just use file dot base name. No. Path. The containing directory, this can be used to create operate base directly on base name rather than path, avoiding the name. Oh, that's dir. Okay. Same as real path, except car must free the return memory. It's fine. Come back to this modules thing here. What I really want is, I care about this. Care about this. What I want to do is once that, I don't need this AST or parser or this. What I don't need is this. Comment that out. We're gonna add the file. Okay. See what this does. Now file name, file dot base name, and let's see, file bytes be adjusted source. Let's see if it likes that. Doesn't like it. Why doesn't it like it? Well, I need to close for today. Thanks for watching, and I will